All right, so in this one, we're going to find the volume of the region in the first octant, so that's where all coordinates are positive, which is inside a sphere of radius 1 and also inside an x squared equals y minus y squared, whatever that is. Okay, well, so maybe the first thing to do is figure out what this equation is. So let's see, so this is x squared plus y squared minus y equals 0. And then I can see, oh, I can complete the square on this sucker. So let's see. So if I have this as being 2 times, maybe make a little bit more room here, 2 times 1/2 y right here, then that means that this, I would need to add 1/4 to both sides. So 1/4 being 1/2 squared. And so if I do that, then this equation can be rewritten as x squared plus y minus a half quantity squared equals 1/4. Okay, so what is this? Well, we're in 3 space, so this is going to be a vertically extended cylinder, and I can tell it's going to be vertically extended because there's no z coordinate in this integral, so that means it's going to be vertical. So let's see, so now I can draw a sketch of my region. So we're in the first quadrant, so set things up like, actually, you know what, maybe I'll make it like this a little bit for artistic purposes. And yeah, so something like this. Okay, so there's my x, y, and z. And then, so this says that we are translated in the y direction by a plus 1/2. So we go out here, and we'll call that 1/2, and then here, and that'll be 1, and that'll be the outer extent of our cylinder. So we have some cylinder that's going to be passing through this. And so if we just go up like that, it won't go in the right place. Okay, close enough. And then at the same time, we also have sphere of radius 1. Oh, okay, so let's see. So, so we have a sphere of radius 1. All right. There we go. Oh, check it out. I almost lined up that cylinder perfectly. Okay, something like this. All right. So now we have to visualize, okay, so what does the intersection of these two things look like? Okay, well, so the cylinder is going to cut some portion out of the inside here. Okay, and then the sphere is going to chop the corner of that off, so it's going to kind of bevel it off like this. That was pretty close to what I wanted. There we go. That's pretty good. Okay. So, this part, oh no! Do that again. This part, and this part here. Okay. All right, so that is the shape that I'm looking for, and there's this dotted line in the back part right there. Okay, so how are we going to set up this guy? Well, the side that we have right here is given by r equals, oh shoot, what is that going to be? Well, let's see. Okay, so you know what? I'm going to go back to this equation right here and figure out how to set that up in cylindrical. And that would be x squared plus y squared equals y. And then that would be r squared on the left is equal to r sine phi on the right. And so I can cancel an r from both sides, and that's r sine phi. So this is r sine phi. Now let's see. If I were going to set this region up in spherical coordinates, then I would rewrite my r as rho oh, sorry, I'm using the wrong variable. That's why this looks strange. That's not rho sine phi, that's rho sine theta. Oops. Oopsie. Correct. Correct. Theta. Okay, sorry about that. So then at this point here, I'm going to get rho sine phi equals sine theta. And this strikes me as being very bad. I don't want to mess with that. That's going to be a nightmare to try and integrate or set up, I think. I haven't worked through it, but my guess is bad. Okay, so that tells me let's try cylindrical first. Okay, so to set up this region in cylindrical, let's get a fresh start over here on the side. I'm going to do, let's see. Let's do dz first. This looks like it's got parallel vertical sides, right? So these sides all look like they're part of a cylinder. So dz first sounds like a good idea. So let's see. So I'm going to go theta, and I have to figure out what theta is this time. It's not totally clear. And then I'm going to have to figure out my dr, and that's also going to take some work. And then I'm going to do my dz, but my dz is going to be more or less clear. It's going to go from z equals 0 up to z equals sphere. And so z equals sphere, let's see. So so this is sphere of radius 1, so x squared plus y squared plus z squared equals 1. And so that's going to be z equals 1 minus, and then this part here is actually r squared. So 1 minus r squared. Okay, so not beautiful, but not horrible. 1 minus r squared. Okay, now let's see. So now so after we do that dz integration, what happens? So then when we do dz, the region that we have left is going to be projected down. It's going to be this half a circle on the positive y-axis that we need to set up. So this is what the shadow looks like when we're done. So now this is where we're integrating that outer double integral. Okay, so let's see. So it looks like we're going to have theta start at 0, and there's going to be a radius of 0 at this point, but the radius is going to be increasing as we go around until we get to a radius of 1, and that's our last theta, because after we get out here, we're no longer in the region, right? Okay, so we're going to have to go from theta equals 0 out to theta equals pi over 2. So that's got 0 to pi over 2 on the bounds of the outermost integral. And then as we do that, we need to figure out what is our formula for this distance coming out across the disk there. And that one we actually figured out already over here. So that's going to be, so we're going to go from 0, because the origin is contained in this object, out to sine of theta. Okay. All right, so let's see. So, and then this is going to be r dz dr d theta, and we're just doing volume. Yes, so our integrand is just 1. Okay. All right, so there is our integral. Let's get a fresh start over here a little bit. start with it all the same color, and we don't need that decoration. Okay, so innermost integral is the easiest one to do, and I can't just pull the pi over 2 out from the theta integral because the theta is appearing up here as well, right? So let's see, so we've got 0 to pi over 2, 0 to sine of theta, and then I've got another one of these that looks like the integral from a to b dz, so that's just b minus a. So I have 1 minus r squared r dr d theta. And let's see, so this is actually just like the exercise from last time. At this point here we have a good idea for a u substitution, and then this will be our du once we figure out. So du is minus 2r dr, so I will take the minus 1/2 over to the other side, and so this is going to be minus 1/2 du sitting here at the end. So we have now integral 0 to pi over 2 times the integral of u to the 1/2 times minus 1/2 du, and that'll give us 0 to pi over 2 u to the 3/2 and minus 1/2 out in front. And what was our thing? It was 1 minus r squared. Quantity to the 3/2. Oh, and I forgot my 2/3. So let's see. So that 2/3 cancels with the 1/2, and we have minus 1/3. There we go. And now we've got our bounds back. So 0 to sine phi, and integrating along on our merry way, we have minus 1/3, and we'll have, let's see, integral from 0 to pi over 2 cosine cubed theta minus 1. And then we can split this into two separate integrals. And so then we have, from the first one, integrating the cosine cubed we're going to have, let's see, so that's, I'm going to think, let me go to the side here. So I've got the integral of cosine cubed theta, and I'm going to think of this as integral of sine squared theta blah 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 blah. Sorry, cosine squared theta times cosine theta, and then this is 1 minus sine squared theta times cosine theta. There we go. So then I'll be integrating a cosine to get a sine, and then I'll be integrating a sine squared cosine in order to get a let me see, so it's going to be taking this guy as my, taking sine theta as my u, then this is going to be my du out here. So I've got integral of u squared is going to be u cubed over 3 . So bringing all this together, we have minus 1/3 times, let's see, there's the sine theta minus sine cubed theta over 3 from the cosine cubed integral, and then minus the theta coming from the 1 right here, 0 to pi over 2. And all of these things are 0 at 0, so I just have to collect them up when they are at pi over 2. So we have minus 1/3, 1 minus 1/3 minus pi over 2, and round parentheses now, And so that becomes pi over 6 minus 2 over 9.